Okay, let's go into short-term forecast mode. We'll start off with the 23 to 0Z analysis that we covered, and then take a look at the most recent short-term NAM 12 kilometer and HER guidance to generate a 0 to 6 hour forecast of the following. One is we'll just look at the environmental conditions favorable for snow bands, both in plan view and sounding mode. Then look at when we expect the onset of falling snow, and then the expected wind gusts and direction with that snow. Along with that, what are the snow and the wind? What are they going to do with the visibilities? We'll take a look at the model forecast and then see and try to extrapolate from there. And then when are those worst conditions of the above parameters going to happen? So along the way, we'll take a look at model differences, biases compared to the analysis at 0Z. Okay, since we're roughly just before 0Z, I think it's kind of close as to whether we get the 22 or 23Z HER at this time. I'm just looking at the 22Z here, and I have the surface winds on all those panels. Again, this procedure has surface winds on all panels except for the lower right, which is a HER specialty. That's the surface wind gusts. In the upper left is the snow squall parameter, and the upper right is the surface temperature. And you see that at 22Z it's substantially above freezing across most of the Cheyenne CWA. Lower left is the visibility in miles, and then we'll have the P-type and reflectivity in the lower right with the wind gusts. So let's advance forward. And as we get into 0Z, temperatures are still well above freezing, and as a result, because of those surface temperatures, much of the reflectivity that we see is falling in the form of rain along this front. You can see the front is dropping south. I think that's pretty much accurate. If we go back to 0Z and 23Z, we saw from the surface analysis that the front was entering the Cheyenne CWA. As we go to 1Z, temperatures are still above freezing, and so much of the precip band along the front is falling as rain until you get west of I-25, where it changes over to snow with surface temperatures around 34 degrees. Visibility-wise, it's not much difference. It's still kind of fairly high because it is a lot of rain, but further west in the snow, it's down to about 3/4 mile. Not quite snow squall conditions, but we'll see. But certainly the wind gusts are high behind the front. We advance this forward, and we'll advance it until we get to where the band starts approaching Cheyenne. So 3Z, it's still north in the city. 4Z, it's really threatening Cheyenne at this point here. Reflectivities are forecast to be around 21 to 22 dBz. And this time, by this time, the temperatures, because of nocturnal cooling, has dropped quite a bit, as you can see, now down well below freezing. And the wind gusts are still forecast to be high, over 40 knots, with sustained winds of about 20 to 30 knots. Now, the HER is forecasting visibility is less than a half a mile at 4Z, just approaching Cheyenne. So that's the point where you have to start worrying. And also, if the snowfall rate, and let's assume the snowfall rate is approaching, half to an inch an hour at this point, it's going to work on the warm grounds. A lot of it's going to melt, but I suspect with those high winds, the ground temperature will fall quickly as the snow takes the heat energy off let's say, the road surfaces. So there is a chance that blowing snow may commence, after some number of minutes, maybe up to a half an hour worth of snow, and the visibilities may drop below what the HER has. So again, there seems to be the HER is depicting an intensification of the snow band as it approaches Cheyenne in the evening as temperatures fall. Everything also converts to snow from rain. Now the NAM 12 kilometer, this is the 18Z run. Let's go back, let's see, right to here. And at 18Z, the front was still in Montana. Temperatures are quite warm. As we go to 21Z, you can see also the temperatures are forecast to be quite high. As we go to 0Z, and notice that we're at 3-hour increments here, so we don't have the temporal fidelity that we had with the HER, but it's still quite a bit warm, and the band is just approaching along with the front, the northern CWA, so right on time with the HER. And as we go down to 3Z, the NAM is a little bit slower, but not too bad compared to the HER. The NAM it doesn't have the visibilities though. At this time, though, you can see that the NAM is generating rain with those warm ground surface temperatures, but as cooling occurs, it automatically changes to snow. We're not getting the visibilities though in that snow band, except in the high terrain here. And later on at 6Z, okay, Cheyenne is in the band. The NAM seems a little slower than the HER in bringing it in. I think the HER, the band was almost done with Cheyenne by 6Z. And I'm just not seeing the visibilities nor but I am seeing the reflectivity. So it's an interesting difference there. But the NAM doesn't have the visibilities compared to uh, the the HER. So a little bit slower than NAM and not quite as alarming for snow squall conditions. Wind-wise, though, we are seeing those 20 to 30 knot sustained winds, so it's possible that we would see gusts in excess of 30 knots, similar to the HER. Now, you might be interested to see what the NAM environment has here, along with instead of the HER, I'm going to go ahead and put the RAP 13 on there. So we'll take a look at the forecast soundings for point A and load that up. Now, again, you might remember here and might have seen it, but that the HER snow squall parameter shows positive values here at 5Z. In fact, post-frontally, positive values come all the way down. They tend to diminish a little bit as the nocturnal cooling cools off the surface layers and the lapse rates decrease a little bit. But we're going to take a look at the RAP 13 versus the NAM 13 soundings. So we're going to go and take a look at roughly about that time. 4Z, this is the point over Cheyenne, and this is a classic example of fairly steep lapse rate still. Surface temperatures, again, roughly around freezing, and with steep lapse rates and relatively high RHs. Just before that, you can see prefrontally, very, very low RH compared to postfrontally, and you can see the RHs really come in, and then by 5Z on the RAP 13, you can see that it's nearly saturated. The nearly moist neutral lapse rates extend all the way up to about close or 640 millibars, or roughly 2,000 meters above ground. And in that layer, I think it is quite easy to generate convection here, given the force lifting by the front and a little bit of buoyancy down here, especially in the lowest 2 kilometers. So that's the RAP 13. The NAM 12, if we go to 6Z, okay, you see that we have similar conditions with the NAM. We got the northerly winds here in the front, not that strong, but again, fairly moist, neutral, buoyant layer, nearly saturated. By the way, with cloud tops down around minus 17 degrees. So with strong lifting and clouds that easily contain lots of ice species, so to speak. It's certainly easy to understand that why there's a snow band right there, and that we have positive snow squall conditions, especially with those stronger winds just off the deck.